onboard intelligence, and a number of other capabilities, all of which will be delivered to the market in our Qualcomm Snapdragon Flight drone development platform. To show us what this platform can do, I'd like to bring out one of our senior engineers who works on drones and robotics for Qualcomm Technologies Research. Let's welcome Sara Gibson. Sara, we've been talking a lot about drones and the major advances happening. Is that what you're going to show us today?
Hi, Steve. Yes, it is. In a few seconds, we're going to launch 3 drones operating on our latest development platform. This is our latest drone technology developed in-house at Qualcomm, and it brings together a lot of the advances you've been talking about. That technology is running entirely on one of these, the Qualcomm Snapdragon Flight development platform, running Snapdragon Navigator software. It weighs just 12 grams. That's less than a AAA battery. Today, we programmed the drones to fly a set course, but we decided to make things a little bit tougher for them. If you look over there, you'll see a bunch of obstacles similar to what you might see in a warehouse. The drones are going to have to avoid them in order to finish the course. So let's see what happens. OK, cool. So now they're up and flying. First, they're going to take a few seconds to orient themselves relative to the markers on the floor. Those will give them their starting positions. Now comes the next big task. The drones do not know ahead of time what they'll encounter in the room. So they're going to have to identify objects that come into view in real time as they navigate the course.
We're seeing some streaming video come in from the drones. Can you tell us what's going on?
So this is live video from the rear drone. As you can see, it's identifying objects that come into view using its camera and an on-device machine learning model. That model is running in the Snapdragon neural processing engine concurrently with Snapdragon Navigator as it moves around the course. That's possible because of our heterogeneous computing design, which lets us combine different functional cores like the CPU, GPU, and DSP. So we can achieve these really high levels of performance while at the same time better preserving battery life. Also, the machine learning capabilities are flexible, so that allows developers to create their own neural networks. The networks can be tailored to use a variety of sensors for their specific use cases. This demo is so exciting because it's the first time we're showing flight control and machine learning running together on a drone.
All that computing is happening on that board.
Exactly. There aren't any external cameras or computing to help them. Usually when you see an autonomous drone demo, there are powerful off-board computers and motion capture cameras that serve as the brains of the machine. But here, everything is happening on the drone itself, all on the Snapdragon processor without any additional specialized hardware. That's important because drones working in the real world will need to do most of their localization and other processing on board.
So Sara, they look to be speeding up. Can you tell us a little bit more?
I sure can. So we really wanted to push things even further here. We can make this happen using the Snapdragon Navigator software. It offers state-of-the-art real-time flight control with advanced safety and autonomous features. Real-time flight control is important. It means the drones can take desired speed and direction and translate them into motor commands. And GPS doesn't work well for positioning indoors. So here, the robots are using machine vision to keep track of their precise position and orientation.
So that works even in a crowded environment?
Absolutely, using a technology called Visual Inertial Odometry, or VIO. VIO fuses input from cameras and inertial sensors so that the drones can fly a complex route like this one with extreme accuracy.
That's a lot of complex technology that has to be integrated to make something like that work.
That's exactly right, Steve. High-fidelity sensing, computer vision, machine learning, real-time control, and navigation technologies. These all have diverse and compute-intensive processing requirements, and we made them all work together on this single board. On top of that, if we want to make sure the drones stay in the air, we need to meet a specific set of power, thermal, and weight constraints. If any part of this had gone awry, the drones wouldn't have been able to make it through the course. So I know I don't need to tell you this, Steve. All of this is really hard to do. Today, drones are often for hobbyists, but soon they'll be patrolling warehouses or even searching for survivors in natural disasters. With 5G and advanced integrated computing, we believe there's virtually no end to what these drones can do.
Thank you, Sara.